Welcome back, polar bears and polar cubs. Let's talk about molecular polarity, aka column 13, lucky number 13. So, how does a molecule have polarity? So, there's some things to kind of take into consideration. They could have a polar bond, okay? They can be considered polar because of their molecular shape, okay? They can also be um, considered polar for having an overall charge. Okay, so when we're talking about the polarity, I'm going to show you it real quick. So if you have, for example, CH4, the bond between C and H, these individual bonds are polar. However, if you have one person that's getting pulled by the same strength, left, right, up, and down, that person's not going to move. They all balance each other out. So this becomes non-polar. So it doesn't have a polarity, so we put a no. What can also happen is you can have, for example, water. Water has these two lone pairs up here. Well, two lone pairs, them all being negative, that puts a big negative charge up here. It's a big negative charge, which then, if you have a big negative charge somewhere, you have to have a positive charge down somewhere. Right here, you have a dipole. Okay, so you have a pole. So this would have a yes for polarity. So really what I'm telling you is there's some kind of chart that we can probably fill in to help us with polarity. So here it is. For three or more atoms. There's four attached. It is a no. Three attached with a lone pair, that's a yes. Two attached with a lone pair, that's also a yes. Now, this is a yes because of the lone pair on the central atom. And this is a yes because of the negative charge. It also has a lone pair, but the negative charge is an automatic yes. Now, if it's only two atoms, nonpolar covalent, which is both the same, or if it's nonpolar covalent, it is no, nonpolar. There is no polarity. Two atoms are different. You have polar covalent. That would be yes. It's polar, therefore it has some polarity. And then a nice little reminder that if it's ionic, 9 through 13 should have dashes. Dashes, remember? Okay. So let's talk about our intermolecular forces of attraction. So in column 14, you can have four different things. You can have ionic. Well, the only time that's going to be ionic is if in column 2 it says ionic. Sorry about that. On number 2, our second thing is dipole. Now, how is it dipole? Well, that means that it has a polar molecule. So, you have dipole if column 13 is a yes. For example, right here, you can see that there's majority electrons around the Cl, making it negative, putting a positive charge right here. So there is a pole. Now, number 3 is hydrogen. Now, hydrogen is a special type of dipole. Okay, it's a special dipole. Now, it is so special that this is actually only happens between hydrogen with nitrogen, hydrogen with fluorine, hydrogen with oxygen. So I'm going to show you with water. Now, with water, this is how it's drawn. Well, water within our glasses has molecules that it can actually interact with itself. This is what intermolecular attractions are. So when it's attracted, the positive dipole here and the negative, they actually can be pulled. So this kind of interacts with itself. When it interacts with itself, this is called hydrogen bonding. This is one of the reasons why water has surface tension. Has surface tension. It's also one of the reasons why water with a molecular mass or molar mass of 18.02 grams per mole has a boiling point of about 100 degrees Celsius. All the other compounds that have 18.02 grams per mole are mostly gases that boil at way lower temperatures. So it's another reason why it is a liquid at room temperature. So hydrogen bonding is a very, very strong dipole. It's so strong, it's a special dipole. And then finally, we have dispersion. Dispersion is just a very weak kind of attraction between the two. So you have Br2, okay, and then you have another Br2, and there's some kind of attraction between the two. You know, it kind of is attractive, but it's not completely attractive. So the last thing that I want to leave you with is strongest to weakest. Well, the weakest is dispersion. And this is when your polarity is a no. Next up is a dipole. This one is when your polarity is a yes. Then comes hydrogen. Which again, polarity is a yes. However, it must be hydrogen attached to N, F, or O. And the top one is ionic. Now, why is ionic have a polarity, though, of a dash? Well, why is it the strongest? Because they're full-on ions. You're getting a full negative and a positive interacting. Okay, it's very, very strong. All right. Hey, Polar Bears and Polar Cubs, that was the end of Chapter 6. I hope you're understanding it to your best ability. If you're not, go ahead and let me know through email, the discussion boards, or even a Google Meet. All right. Have a good one.